All right, sixth graders, let's finish up our energy unit. With the marble experiment, you should have seen that kinetic energy was transferred from one object to another. So when you had your marble sitting at the bottom of the ramp, or object sitting at the bottom of the ramp, it was sitting still. No potential energy because it couldn't fall, and no kinetic energy because it wasn't moving. Your other object at the top of the ramp had potential energy as it was sitting there, and kinetic once it starts moving. So kinetic, it hits, and that energy gets transferred to the other object, which then has kinetic energy and moves. You should have maybe seen, depending on the size of your objects, that this one stopped. That's because all its energy got transferred and was put into the second object. That doesn't happen every time. It depends on a lot of things, but you could have seen it. Vice versa, when you had your small object up top and it rolled down, it still has got kinetic energy. It hits the object. That kinetic energy goes in here. Depending on the size of your objects, you may or may not have seen movement. If your large object was really large, then it may not have moved. And that's a concept that we cover in 8th grade, that there's a certain amount of energy to get the big object moving. So the small object sitting on the bottom is a little bit easier to understand, that the kinetic energy got transferred. That's the same type of idea that's used in Rube Goldberg machines. That objects are sitting still, just waiting until a moving object comes and hits the thing before it, and that gets it to move. That also shows kinetic energy being transferred. So that was experiment 1. Experiment 2 was your skate park. With your skate park, you should have seen that, wow, I've got all sorts of them there. Okay. You should have seen that when I put my skater up top, I've got a bunch of potential energy. The potential energy is equal to the amount of total energy. As it starts moving, the potential energy goes back and forth, up and down, up and down. At any point when I pause it, if I could stack these two, the kinetic and the potential bars on top of each other, you'd see that they equal the amount of total energy. It's easy to see when it's almost at the top, because you can see it's just a little bit short of total energy. How much short? Well, that much. What that shows us is that the total amount of energy that's going on here is always the same. Just sometimes it's potential and sometimes it's kinetic. Then we went to the friction experiment and we took it up a notch. So here we are, same setup, same total energy. It's all potential right now. When I start it, it still bounces back and forth, but this time I see the thermal energy going up and up and up. Where is that from? Well, it's from the friction, from the wheels. Just like when we rubbed our hands together, right? And it gets warm. Eventually, as we let this skater go and go and go, it stops moving completely. And that's because all the energy that was there has turned into thermal energy because of the friction. If I were to touch these wheels right now, they'd be really, really warm because they were moving so much and rubbing so much and they got really hot. So there's still energy here. It's just converted into thermal. Resetting it, the same applies, that I can pause this at any point, and if I could add these 3 bars up, they would equal the same total amount of energy. That's transformation of energy, that we have a certain amount, it just sometimes is in different forms. It's kind of like in an equation, when there's lots of different ways to equal 4, I can have 4 equal 4, I can add up a bunch of things, I can add up 2 plus 2 equals 4. That's the same idea. It's like adding potential and kinetic to get the total, or adding the potential and the kinetic and the thermal energy to equal the total. Same idea. So overall, in this whole unit, what you should have learned is that there's potential and kinetic energy. Potential is based on position, kinetic is based when it's moving. We also talked about thermal energy, which is heat. That heat often comes from friction. Friction happens because objects aren't smooth, they're rough, and rubbing them together creates heat. Then the last thing that we learned is that energy can transform and transfer from one type to another, from one object to another. If you have any questions, let us know. Finish up the conclusion questions on your doc and then submit it to Canvas. And next time we move on to space.